Everyone calls these new AI facilities data centers. That's fundamentally wrong because the nature of what is being created and the purpose for which they are being created are absolutely different from traditional data centers. This is the perfect example of why language is so important. By using data center, the language is obscuring the truth of what is happening. A data center is a place where information is stored and moved. If you send an email, it routes it. If you buy something online, it processes that transaction. If you stream something, that's all routed through a data center. But what's happening here is not the storing and moving of information. We are creating an entirely new resource. We are scaling and training and distributing intelligence, non-biological intelligence with a capital I. My name is Nina Schick. I'm a sovereign AI strategist. I've been focusing at the intersection of AGI and geopolitics. It's been my beat for over 10 years now. I had a bottled lightning moment almost 10 years ago when I really started to believe that what was happening at the frontier of deep learning and what was happening at the edge of AI was going to become the most important human and geopolitical story of the 21st century. I started to believe that we are going to be able to scale the capability of non-biological intelligence so it becomes a general purpose capability and matches human intelligence. And not only are we able to scale non-biological intelligence to match or even go beyond human capabilities, but we'll be able to broadly distribute that capability like an industrial scale resource throughout the economy and the society. That essentially means that non-biological intelligence is going to sit underneath everything like a utility while it's constantly improving, and looking at it from the perspective of geopolitics or society or what it means to be human, there couldn't be a more transformational moment in our 200,000 years of human history. So what Elon Musk is building in Memphis, in Tennessee, and across the border now in Mississippi is the perfect symbol of what it means to scale and build non-biological intelligence. This is the world's largest, shall we say, intelligence factory. And the story of how he built this is truly incredible. So this site in Tennessee was a place where a Swedish appliance company used to manufacture refrigerators. They moved out in 2020. A few years down the line, Elon Musk decided he would start training Grok, his AI model. He went to the traditional data center providers to ask them to build him a facility to scale intelligence. And what he found was that the lead time was going to be 4 to 5 years. That was way too slow. So they went into Tennessee, into this discarded appliance factory, and they completely gutted it and started building their own intelligence factory. They moved into this disused refrigerator factory, completely gutted it, and immediately hit problems. They found that the local grid could only supply them with 8 megawatts of power. They needed 150. They found that the cooling system in the facility was basically air conditioning, was not fit for purpose. They needed to build a custom-made liquid cooling system, which they did with Supermicro. They actually had to bring in wind turbines and strap on Tesla kind of battery packs to the outside of the facility to deliver the power that they needed. And within 122 days, they were able to wire together with the electricity, with the cooling, 200,000 NVIDIA H100s, a feat that Jensen Huang said was superhuman, because traditionally building something at this scale with this complexity would take about 4 to 5 years. So it shows you how with brute force and a mentality of wartime building, Elon Musk was able to scale the largest intelligence factory in the world. Right now, the site has over 500,000 GPUs. It's actually expanded to over 3 buildings. And by this year, 2026, I think that they are going to have wired together 1 million of the most sophisticated GPUs. This is going to be the world's largest hardware cluster. It's on track to be powered by 2 gigawatts of power. That's enough for 1.5 million American homes. So Call that a data center. It's a completely new type of infrastructure. It's an intelligence factory, and it's no surprise that someone like Elon Musk is building the biggest one in the world at the most accelerated velocity. They're building a water facility next door, an $80 million water facility just to recycle 13 million gallons of water today, because at this scale, at this density, at this heat, if you don't have that water cooling the hardware literally melts. Jensen Huang called this superhuman, and it really was a superhuman feat. The scale of engineering required to build Colossus is just staggering. And of course, it helped Elon Musk that he had access to the world's best engineers through SpaceX and Tesla. It would normally take something like 4 to 5 years to do something like this. In 122 days, that's faster than it would even be to get a lease on a normal site. So truly astonishing, showing again what the stakes are and treating this like a wartime build. Beyond Colossus, this is happening more broadly across the United States. If you look at the hyperscaler CapEx in the United States just this year to build intelligence factories, we're looking north of $700 billion. That is double the CapEx of last year. So the pace isn't slowing. At the 3 Colossus sites, a third one has just been acquired across the state line in Mississippi. There are already over 500,000 GPUs being wired together. By 2026, we're going to have the largest compute cluster in the world. I think we are going to reach 1 million GPUs, 2 gigawatts of power. And just thinking about how much space is required, it's over 2.5 million square feet. So everything in an intelligence factory is completely different from a traditional data center. Even if you just look at the power in a traditional data center, a rack would draw something like 8 watts of power. But in an intelligence factory, based on the hardware that is operating now, you're looking at something more like 200 watts. So that's 25 times more. And this changes everything, how you run the cooling systems, the engineering of the building. And this engineering problem isn't even static, it's an accelerating one, because the next generation of hardware that is already being built and developed, you're going to be looking at racks that draw something like 600 watts of power and eventually 1,000 watts of power. So even thinking about how you sustain the floor of this building, which is going to require massive cooling systems. It has to be reinforced at something like double what a traditional floor would be reinforced at. The copper wires required to engineer the heat and take out the heat in the system is something that you'd see in a steel mill, not something that you'd see in a traditional data center. So the power draw, I think, is one of the most fundamental parts in understanding how everything downstream of that in terms of engineering is fundamentally different from a data center. So an intelligence factory is fundamentally different from a traditional data center. One of the first things you can look at is simply the power draw. A server rack in a traditional data center will take something like 8 kilowatts of power, but a server rack in an intelligence factory, you're already looking at 200 kilowatts of power. And that's just for this generation of hardware. Down the pipeline, we're already developing the next generation of chips that are going to draw 600 kilowatts and then 1,000 kilowatts of power. That is enough to power an entire small town, all within the space of a unit that's roughly the size of a refrigerator. If you take that consideration, then downstream of that, everything fundamentally changes in the engineering of this building, the cooling that's required to sustain this hardware so that it doesn't melt. And bear in mind, the kind of computations that are being done in an intelligence factory requires the chips to be working in tandem all together. So if one part of the hardware melts down because it gets too hot, then the entire intelligence factory, the entire capability is compromised. That's why you're looking at cooling systems that weigh up to 3 tons. The floor of these buildings has to be reinforced almost double to what a normal floor looks like, and you need copper wiring throughout the building, which is more like what you'd expect to see in a steel mill rather than a data center. So the fundamental engineering of these facilities or intelligence factories is completely different from a traditional data center. And every watt of energy that's consumed in these facilities also goes through as a watt of heat, a watt of waste. And if you're running a facility like Colossus will be doing at 2 gigawatts of power, you are generating approximately 1.8 gigawatts of waste heat, which is why you need these phenomenal kind of liquid cooling systems. 1.8 gigawatts of waste heat is about the same capacity as a small thermal volcano. So let's talk about cooling for a second. When Colossus was being built, the bespoke cooling system wasn't ready yet, so they had to rent mobile cooling systems and took up a quarter of the entire supply of mobile cooling systems that is available in the United States. Because if they hadn't done that, then you'd be compromising billions of dollars of hardware, which would literally melt down as they are working so hard to connect with each other. On that point, networking is another facet that just has to run in complete, perfect synchronicity. In a traditional data center, the chips talk to the outside world. Here, they are all talking to one another, running in tandem, running parallel computations. So if a single chip or a rack melts down, then that compromises the validity of the entire operation. So you need near zero latency, perfect networking. And again, on all of these fronts, from the networking to the cooling, to dispersing of the heat, to actually building the infrastructure itself, the engineering challenge is monumental. Then networking. Within a traditional data center, the data centers speak to the outside world, whereas in an intelligence factory, these chips have to work in parallel. They're doing parallel computations, talking to one another at near zero latency. And there cannot be any blip on how these chips communicate with one another, because then that could compromise the entire operation, the entire training run. So to ensure that those chips are all working in tandem perfectly together, the networking challenges are simply immense. The internal data traffic of a single intelligence factory is larger than the internal internet of most countries. These intelligence factories are overwhelmingly being built in the United States. So according to Epoch AI data, over 75% of the world's most advanced compute capabilities, and by this I'm speaking about these intelligence factories, are now located within the US. Europe has less than 4%, and according to Epoch AI, China has about 15%. And what's really interesting is that this is moving into the American South and into the American heartlands. If you look at some place like Northern Virginia, which used to be data center corridor, where most of the world's internet traffic used to be routed through, this is changing. It's places like Ohio, Texas, Tennessee, Mississippi that are housing these new sites. Let's zoom into Ohio. You have sites like Prometheus, which is Meta's bespoke intelligence factory, which is coming online. Unlike Colossus, which is spread over 3 sites, this is one site being built from the ground up, and this is also going to be another gigawatt data center. So already in the United States, we're talking about several sites that are serving 1 or 2 gigawatts of power. It isn't just XAI, it isn't just Meta. Google, Amazon, Oracle are all building in Ohio as well. I'm based in Texas. I like to say that Texas is going to be ground zero for AGI, in part because of the sheer infrastructure that is needed to support intelligence to civilizational scale. And by 2030, Texas is actually going to overtake Virginia as the #1 market within the US for intelligence factory capability. Right now, in Texas, over 6.6 gigawatts of power already being permitted to support these data centers. What's really interesting is how now the US hyperscalers are starting to think about how they can sustain their own energy capabilities on site. So by not connecting into the local grid where capacity is already very, very stretched by doing things like building small modular reactors on site, and in the initial phase, at least, powering up through things like natural gas, which is why Texas is such a hotspot. So these intelligence factories are flooding into the American South, into the American heartlands. And the formula is basically, where can we get a lot of land? Where can we get access to energy? Where can we do the permitting and regulation quickly? Which is why places like Mississippi, Tennessee, Texas, Ohio are emerging as ground zero for these sites. If you look at Prometheus, which is Meta's big site, which it's developing in Columbus, Ohio, it's fascinating to see how they're already locking in deals with the local energy providers specifically for nuclear. This is a site being built from the ground up to be powered by nuclear energy, already signed 3 deals as of January 2026, locking in 6.6 gigawatts of nuclear energy to power this one intelligence factory. 3 local nuclear facilities, which might have otherwise have been phased out, are now extending their lifespan thanks to this kind of underwriting by Meta to buy the energy resource. We're also starting to see in places like Ohio how local utility providers simply aren't signing any more deals because they don't have the capacity, right? If you look at Ohio, I think there's something like 33 gigawatts of energy already signed for, and there simply is no more capacity. Just thinking about the actual scale of this infrastructure, it almost boggles the mind. So Meta's Hyperion site in Louisiana, the initial price tag on Hyperion was $27 billion. And now it looks like that bill has already escalated to over $50 billion. That is larger than the entire island of Manhattan. So again, we need to completely reevaluate how we think about this infrastructure. It's not a traditional data center, and therefore also think about why are they being built? And it is being built to industrialize non-biological intelligence with a capital I. So Stargate is a very instructive story of what's happening right now with the build-out of these intelligence factories. It was announced to great fanfare in the White House soon after President Trump took office as the largest AI infrastructure investment in history, $500 billion. A year later, it's being built. You know, there are 10 buildings coming up in Abilene, West Texas, 6,000 workers. The promise was 100,000 jobs. But the reality is that it's messy and it's hard. So there has been a lot of bickering amongst the partners of this joint venture, OpenAI, Oracle, and SoftBank, about the financing, who's going to own the land, how is the money going to be deployed. Famously, Elon Musk tweeted right after the Stargate announcement that they didn't have the money. But I think there's 2 takeaways that we can take from the Stargate story. First, it's being built, not as quickly as was kind of portrayed in that press conference. You can't just press release yourself to kind of 10 or 7 gigawatts of energy. So it's happening, it's messy, it's slow, but it is happening. And the second takeaway, I think, is again, just understanding the sheer difficulty of this as an engineering challenge. So to build these intelligence factories that are serviced by 1 gigawatt, 2 gigawatt, 3 gigawatts of power, you need an intense amount of resource, you need an intense amount of capital, and you need an intense amount of talent. And I know that's certainly in places like West Texas, where a lot of this infrastructure is coming up. There's a real dearth in the people who actually know how to do this. You know, where are the engineers? Where are the electricians? Where are the builders who can do this? So it's messy, it's slow, it isn't as dramatic as was pronounced a year ago. It's expensive, you need the right people, but it's happening. Guess what? It turns out that building hardware and the physical infrastructure to support intelligence at this scale, it's actually hard. So from where I sit right now, things don't look too good for Europe. And I really say this as somebody who's European and wants Europe to do really well. There are several problems, and let's break it down. So first of all, let's start with the capital. with the money. The European Commission announced its Invest AI initiative, which aims to invest 200 billion euros over 5 years to build AI infrastructure, to build intelligence factories. 4 sites to be developed across Europe with 100,000 GPUs. Let's go back and look at what Elon Musk was able to do in 122 days. He was able to wire together 200,000 GPUs, and the EU's aiming for 4 sites with 100,000 each by 2028. So the chasm in terms of capability and hardware is huge. But even beyond the money, let's look at the actual grid and energy requirements. So it's infrastructure and energy that are the huge strategic blocks. Being even connected to the grid, if you are a traditional data center, let alone an intelligence factory, typically requires about 5 to 7 years. In Germany, which is the EU's largest economy, it's an average wait time of about 7 years. And fascinatingly, and also this isn't a good signal for Europe, you're already starting to see how key cities that have been servicing data center traffic, so not intelligence factory traffic, but data center traffic, Dublin, Amsterdam, have already signed moratorium on building new infrastructure because the grid simply doesn't have the capacity to cope. And then this also becomes a structural problem with energy. We know that Europe is a net energy importer. Of course, the energy balance within the EU27 is different when you look at it country by country, but overall, the bloc is a net importer of energy, lots of LNG from the Gulf and the United States. This means that when Russia invaded Ukraine a few years ago, this was a complete disaster for Europe because the cheap Russian gas, which it had been dependent on, was almost shut off overnight. Industrial energy prices in Europe are far higher, 3 to 4 times higher than they are in the United States or China. The most expensive industrial energy prices in the world are in Germany and in the United Kingdom. So sustaining the kind of energy requirement that we're talking about, multiple gigawatts of power, is simply something that the EU cannot support because it is a net energy importer, and looking also at how outdated its grid is. And finally, just looking at the sheer amount of capital that's flowing into the space, it is a rounding error in Europe as compared to what's happening in the United States. So to put it succinctly in the kind of words and sentiment of Arthur Mensch, one of the founders of Mistral, which was supposed to be Europe's answer to an AI frontier lab, whilst the United States is building the equivalent of 3 or 2 Apollo programs every year, Europe is building excellent regulation. And he's right. So again, to look at the scale of the difference, if you compare Europe to the United States, Mistral, which was seen as the forerunner for European AI frontier capability, announced a capex plan of about €1 billion for 2026 and a data center in Sweden for 1.2 billion euros. That is just a rounding error when you look at the scale of investment that I've already highlighted, 700 billion between the US hyperscalers in the US in 2026 alone. So the capability gap is vast on capital, on infrastructure, and specifically how that relates to energy infrastructure and existing grid capability. When I say sovereignty is downstream of intelligence factories, the first distinction I want to make is that intelligence, non-biological intelligence, is going to become the most important resource of the 21st century. So whoever has the infrastructure to build and own and scale that intelligence to transformational impact is going to become the most powerful. Because if you think about what matters for sovereignty, it goes to a question of economic prosperity and also security. If you own the intelligence that's going to be broadly distributed in military capability, for economic growth, for the markets that are going to be important in the 21st century, you own the fundamental resource that's going to set the tone of the 21st century. However, a second point, which is really interesting and important to distinguish, is that we're starting to see that frontier capability, so having just the most sophisticated model, right? Having the best AI model is not a moat. And what I mean by that is that the best model and their capabilities can be distilled. That capability can be stolen. That capability is never going to be kept behind a locked wall. It's going to disperse throughout society. So if the moat is not the model nor the frontier capability, what is the moat? The moat is actually going to be the infrastructure that builds that capability, but then can also broadly distribute that capability to transformational effect across your economy and society. So it's the infrastructure, it's the intelligence factories, it's everything that goes into creating those intelligence factories that's going to scale and then sustain the capability, which is non-biological intelligence, that's actually going to be the moat. It's going to be the most important arbiter of sovereignty and power. The moat is not in the bits being the model capability, but it's actually in the atoms. It's the physical hardware. It's the manufacturing capability. It's the energy, everything that's required to sustain intelligence at this scale. The DeepSeek moment, where they claimed they trained a model for $6 million, which then wiped off over $1 trillion of market cap of the US stock market, is the best PR I've ever seen. Because that number, the 6 million, is fundamentally misleading. The 6 million is what was used for the final training run. However, there's no mention of the over $1 billion spend DeepSeek's parent company spent before we got to the final training run. And there's also no mention of the fact that DeepSeek was able to stand on the shoulders of American giants. Just this week, we've heard the US lab, Anthropic, and previously we've heard OpenAI and Google also saying how they're coming under industrial scale assault for their model capabilities being stolen through concerted IP extraction campaigns coming from DeepSeek and other CCP-backed Chinese labs. So they're stealing and distilling US capability. So all of those billions of dollars that are going into kind of the hardware and the training and the scaling in the US is something that they're able to take out. And then there were real engineering efficiencies. So the algorithmic breakthroughs that they did in order to run the model or run inference on the model 90% cheaper, that is really some very, very clever mathematics. So full credit to the engineers for being able to do that. However, to say that this model was built on 6 million is simply misleading because it's just some clever accounting on what was spent on the final training run. So what is interesting about the DeepSeek moment is that it shows that once you've innovated at the frontier, it becomes very easy to catch up to the frontier and a lot cheaper. But innovating beyond the frontier, right? Pushing out the boat beyond what's capable now, that's what's really interesting. And that's what I'm still seeing primarily coming from the US labs rather than the Chinese labs. You can catch up to the frontier, but can you innovate beyond the frontier? And therefore, if the frontier capability of the model is not something that's a moat, it's not a competitive advantage because everything you create at the frontier can be distilled and stolen. You have to think about where the real competitive advantage comes from. And my belief is that is in the infrastructure, in the actual physical footprint of the intelligence factories that are going to help you get beyond the frontier. Now, I think we're in for another kind of DeepSeek moment 2.0 because the markets simply don't understand what's happening with AI. Actually, nobody really understands. Nobody knows where this is going to go. So we see so much market volatility. That 1.2 trillion we saw wiped off the US market when DeepSeek dropped its model and made those claims of 6 million. We'll see another moment of those because right now, the Trump administration has admitted that there is a kind of secret facility in Inner Mongolia where DeepSeek is training its latest model with access to NVIDIA's Blackwell chip. NVIDIA's Blackwell chip is the most advanced GPU that's on the market right now. These are chips that are actually illegal in China, so they've illegally obtained these chips. They're training their latest capabilities on these chips, but what they're going to do is strip out any kind of evidence of the American hardware. They're going to claim that this was all run on Huawei hardware. This wasn't American hardware. And of course, there's going to be no credit to the intelligence that they've distilled and stolen from the American labs. So it's going to be stolen American hardware. illegal American hardware, distilled American intelligence, and then with some very, very clever engineering, I expect that they'll be able to make a leap in terms of cost, or say that they did this far cheaper, and that will probably lead to another market shock. But if you look underneath the numbers a little bit and you look at the infrastructure, the truth is a little bit more nuanced. DeepSeek says it costs less than $6 million to train their model. That number is technically true in the same sense that a flight across the Atlantic only costs the price of the jet fuel. But that number ignores the airport, the pilots, the decades of engineering it took in order to make that flight possible. The way they came up with that number is they took the 2.8 million GPU hours it took to push the final training run for the model, and they priced it at $2 an hour, which is typically the going market rate to rent an hour of compute from an H800. As the scale of this infrastructure is so vast, we're going to see how public opinion starts to shift. So already across the United States, you've seen utility prices jump by 12%. And in Northern Virginia, which is where traditionally the traditional data centers were housed, you've seen utility prices jump by much higher than that. In a single quarter of last year, due to local opposition, you saw almost $100 billion of projects being stalled, local communities coming out and protesting that they don't want this built in their backyard, not only because of the utility price jumps, but also because of how vast the infrastructure is and the knock-on impacts on water, on environment. And again, going back to the example of XAI, you can see how local communities are starting to rally against this. So I mentioned how Colossus, in order to get Colossus up and running, XAI needed to kind of bring in gas turbines to supply the power that was needed because the local grid can sustain power at that scale. Now, they're facing legal action, that they didn't have the right permits, that they broke environmental regulations. So this pushback is much more than NIMBYism. It's really going to become, in my view, one of the biggest political push points in the next few years, especially as we start scaling and building towards AGI or increased capabilities. The fear about displacement and automation combined with the physical impact of these intelligence factories and how it affects local communities is going to become one of the biggest, most contentious political stories. The people versus AI is one that we're going to have to watch. You're already starting to see how some PR-savvy hyperscalers, for instance, Microsoft, are starting to pitch these initiatives as being community first, right? They're saying that when they build an intelligence factory, they are going to ensure that the utility prices for the community do not jump, that they will pay for local utility prices, that they will make sure that the quality of the water is better, that they will make sure to create local jobs, that they will make sure that they will use some of their R&D budget to invest into local communities. And you do see how differently communities across the United States are already starting to react in places like Texas, where this is seen as a massive boon for the state, where it's seen as a huge job potential creation opportunity. You see state legislators saying this is going to give them an economic and competitive advantage, whereas in other states, there have been moratoriums signed on the building of data centers. Denver was one recently, and you have politicians like Bernie Sanders saying that we should call for a federal ban, a federal moratorium on the build out of data centers. So this is going to become such a divisive political issue, and it's one I think that is going to fracture across political lines, whether you're on the left or on the right, and also depending on where you're geographically located in the country. And because so much of this tension starts at the price of the utilities and connecting to the grid and consumers starting to see their electricity prices jump, that is why all of the hyperscalers are working towards more medium to long term being able to generate their own power on site that completely bypasses the grid. So that is why every single hyperscaler has signed deal with a nuclear provider to build small modular reactors on site to actually be able to power their intelligence factories without impacting the price of utilities more broadly in the community. If this is just the beginning, what comes next is something completely unprecedented. So 2025 was probably the last normal year. I see two things really coming together this year. The first is the extreme takeoff in terms of capability, what these frontier models are actually able to do. And then the second is the intense geopolitical competition that is driving the market and that is fundamentally, in my view, reshaping the balance of power globally. So you have increasing capability, increasing competition. What that translates to in the real world in terms of intelligence factories is expect bigger clusters, expect more capital investment, expect more competition, expect the stealing and distilling of these capabilities as it becomes the number one issue in terms of sovereignty and national security, and new alliances as this most fundamental, vital resource of non-biological intelligence is scaled in the intelligence factories, but will also have a transformational impact on security and the economics of what happens next. They're not data centers, they're intelligence factories, they're being built. This is the most amount of CapEx we've ever seen on infrastructure. And the end result is that non-biological intelligence is going to be scaled, both in terms of its capability, but also its broad distribution. So whoever owns the means to control and build and distribute the most valuable resource of the 21st century, they are going to be fundamentally extremely powerful. And this race to not only build the most capable intelligence, but to own the supply chain and the means to deploy it and broadly distribute it is going to rewrite the balance of power.